Veteach. Today we will discuss about activity diagrams. So what is an activity diagram for? An activity diagram shows the flow from activity to an activity. An activity is an ongoing non-atomic execution within a state machine. So specifically tell you what an activity is, it's an operation that is taking place. That can be represented as an activity or an action, an activity state or an action state. So an activity diagram consists of an activity state and an action state. An activity state is a non-atomic in nature, where an action state is atomic in nature. So what do you mean by an action state? Is a behavior that cannot be further split is represented as atomic, and so an action state. An operation that can be further split can be represented as non-atomic, and so it is an activity state. Followed by an activity diagram consists of transitions and objects. And objects also add-ons the activity diagram. So what are these action states and activity states? As indicated, flow of control is actually shown among activity to activity in an activity diagram. So an action state or an activity state plays the roles of states in this diagram. So they can be part of objects, where the objects are sending a signal or receiving a signal or trying to create another object or destroy another object. All that can be rendered as an action or an activity state. So representing a state is representing the state and relationship among the states, the transitions among the states will indicate you an activity diagram. So the atomic computations are the action states. So here to bring up the example how the action and activity states are represented, you see here there are two states. An action or an activity state is represented in a similar way, two parallel lines and a soft edge, convex edges on two sides of a rectangle is an activity state or an action state. Physically representing both of them are the same. But you see here there is a process involved in bid plan, so a simple action, and there is an expression written in one. So which is an expression? An action state, which is a simple action, or an expression? Yes, any of them is written as a activity or an action state. And when you try to represent links between these action and activity states, we call them as transitions. A transition can have a lot of adornments over it. A transition is shown by a simple directional arrow. So which is represented like this. But when you see here, there is some word used here which is called as triggerless transition. This transition that I was talking about can be taking the control from one action to another action, one action to the second action, without having any guard conditions. G-U-A-R-T, guard conditions. What do you mean by a guard condition? When should the control flow from first activity to second activity is based on a condition. If no condition is being applied between one state to another state, then such a transition is called as triggerless transition. But when you write a guard condition, it becomes a triggered transition. So a triggerless transition and a triggered transition. A triggered transition carries a guard condition over it. So what do you mean by a guard condition? Guard condition is something that you tend to write as a message or a condition. When on satisfying that condition, you will change from one state to another state. If the condition is not met, you are directed towards another state or nowhere. So in a sense, where do you go can be decided with the help of a guard condition. So the example shows here how an event can be triggered. So see here that there is a release work order. But when I move the control from release work order, I see there is a guard condition here, an expression being indicated within the square braces. Within the square braces, the condition is materials not ready. What happens if the materials are not ready? We know that we cannot release the work order. We cannot send the items. We cannot ship the items. So we have to reschedule. If the materials not ready is true, then we will reschedule it, or if it is false, indicating that the materials are ready, I will assign the task of shipping the items. See here the conditions that the conditions that I have represented here in the square braces are called as guard conditions. So these the transitions that we have represented in this activity diagram are called as triggered transitions, where in the previous transitions you tend to see that there are no such guard conditions expressed, and so these are triggerless transitions. In any case, triggered transitions or triggeredless transitions are applicable in activity diagram. Another property that is very keenly applicable in activity diagram is fork and join. Forking and joining. So what do you mean by this fork and join? The flow of control from an activity can be split. Flow of control from an activity or an action state can be split with the help of fork. So what does a fork do? It splits the flow of control. So one flow of control can be the output of one activity or action state can be given to multiple action or activity states, then that is called as forking. And what is joining? In an activity diagram, the flow of controls that are split have to be combined together again to generate one flow of control and give it to an action or an activity state, which is done with the help of join. So a fork and a join are used to generate concurrent flow of controls or to merge the concurrent flow of controls. So how do we do that? How do we render them graphically? So see here the example. There is a horizontal line. There is a horizontal line represented just below the prepare for speech activity state. So you see here the flow of control, the trigger, the transition is being on a horizontal line. The horizontal line now is called as a fork. So what does a fork do? It splits the flow of control. It generates concurrent flow of controls. How many did it generate? It generated 1 and 2 concurrent flow of controls. So these two flow of controls have to be merged together with a join. So what does a join do? It merges the concurrent flow of controls into one flow of control. So one flow of control has been split by a fork and concurrent flow of controls have been merged by using a join. And how are those rendered physically? Those are graphically rendered by using a horizontal line, bold horizontal line among the transitions. When you do that, you will call it as a fork and join. Please see that there is another fork and another join. So one of the flow of control 2 has been split into 2-1 and 2-2 and 2-2. There is a concurrent flow 2 has been split into 2-1 and 2-2. What happened to that 2-1 and 2-2? That 2-1 and 2-2 has been equivalently merged together into 2 again. So I see here that forks and joins, the number of forks and number of joins have to be balanced. So the number of concurrent flow of controls that you generate should always be equivalent with the number of flow of controls that are merged together. So equivalent should be drawn. So I see here that this is a join, this is its fork, and this is its equivalent join. So when I do that, so equivalent joins, equivalent forks. So there is a fork 1, fork 2, and this is a join 2 and this is a join 1. So I mean that join 1 relates to fork 2 and join 2 relates to fork 2. So equivalent number of balancing the forks and joining is quite needed. So what did this fork and join do? They have split the flow of controls and they have merged the flow of controls. Another important property that is applicable over an activity diagram is swim lanes. Swim lanes, the property called as swim lanes. Certain times the interactions between these activities and actions are so done that the set of activities are grouped together to form a swim lane. See here, there is an example. See, there is a customer swim lane created. There is a customer swim lane created. The customer swim lane consists of then an action, request protocol, request product, receive product and pay bill. In a sense, if I say that there are a number of actions and activity states being represented, if there are a number of actions and activity states represented, all those can be categorized into those which are being operated by those objects or the actors. So there are three objects that have been represented. One is a customer, two is a sales, and three is a warehouse. So I am splitting my action and activity states basing on that. So what are those swim lanes? Swim lanes are the vertical distributions. Swim lanes are the vertical lines that split your action and activity states. Look at this diagram. This shows how an order placing of certain items can be done here. So a customer searched for some items and made a request for a product. Request of a product has been split by using a fork. So I'll write it as fork 1. So what happened here? This is a horizontal line. So the controls have been split. As I split the controls, one of the control went into the another swim lane, which is process order. Yes, the requested product order should be processed by sales, whether it is available, not available, possible to ship, not possible to ship. There are so many cases which are handled by the sales. So the process order has been processed, and as I see, there is a control here indicating that there is some object created here. What is the object here created? So I see there is an object here. I call this as an object because there is an underlined name, order. The object here is an order. So the object order is associated with your process order. So adding objects into activity diagram is also possible. But remember here, what is this in order? It's called as the status. The state of the object order. So what is the status of the order? It's in progress, which you have put it in square braces below the name of the object, which is a tagged value. So anyhow, as I do that, there is a pull material in the warehouse. From the warehouse, I pull the material, ship it. As I am trying to ship it, I know that this control has to mix it with the request order. So there is a join, equivalent join here, which is merging both of them and generating another one. A receive order by the customer. As the customer is receiving the order, the sales is generating a bill for the customer, which is being passed again to the customer for him to pay. So the actions, the activities among these three object lanes are being indicated physically by swim lanes. So vertical distribution of this objects are called as the swim lane. So what are the names for each swim lane? One is a customer, two is a sales, and three is a warehouse. So that's how we do the object flow. And why do we call this as an object flow? We call this as an object flow because there are objects involved. You can see that it is in progress, but the same object, when I see here that when the order has been shipped, I find it to be filled. The status has been filled. The same order is there is another object created which is called as bill, which is unpaid, but after paying it changed into paid. So the object status, flow of object can be understood with the help of object flow. So and swim lanes. So what is an activity diagram used for? An activity diagram is used for to model workflow. So how do I model workflow? I tend to use swim lanes. I can use swim lanes. One is a swim lane. Two is use of objects. So use of swim lanes, use of objects is called as modeling workflow. So how do we model an operation? You can model an operation by simply representing a small activity diagram with representing guard values, few guard values. See here, there is a decision box involved here, as in the case of a flowchart. So you see here a decision box which is deciding which way to direct the flow of control, that is basing on a decision, a guard condition being used. And an activity diagram always starts with a start state and terminates with an end state. You can have more than one end state also. So a start state is represented by a filled circle where an end state is represented by an outer circle and an inner circle, a filled inner circle. So this is an end state, and you can have guard conditions, expressions, anything in the action and activity states. You can reverse and forward engineer your activity diagram also. So we know that forward engineering is a process of converting your model into code, and reverse engineering is a process of converting your code into model. So all those both are feasible for an activity diagram. Thank you.